Think about this. What if understanding a few simple principles could unlock the secrets to the most complex systems on Earth? Good day everyone, I'm Carl James B. Solosod from BS831 and ngayon, we will dive into the science that makes it all possible. In today's video, we'll be navigating through some fundamental concepts and applications about the incompressible flow, conservation of mass, and Bernoulli's principle. And not only that, because in the latter part of the video, itatackle din natin yung ibang sample problems. So these example problems will help reinforce our discussion and show kung paano ito na-apply sa real-world scenarios para magkaroon tayo ng solid foundation in aerodynamics and its practical application. So without further ado, let's get into our discussion. So for our first topic, we have incompressible flow. When we say incompressible flow, it refers to a flow in which the density remains constant. So presented in the screen is some of its characteristics. So for the first one, we have density is constant. In incompressible flow, the fluid density remains constant throughout the flow field. Ibig sabihin that regardless of pressure changes or velocity variations, yung density ay hindi mag-fluctuate. Yung assumption na ito simplifies fluid dynamic calculations, especially when applying principles like Bernoulli's equations or the continuity equation. So for the second characteristic, we have velocity less than 100 meter per second. So at velocities below 100 meter per second, yung changes in pressure due to motion ay sobrang liit that they don't significantly affect the fluid's density. This is often true sa mga low-speed airflows and liquid flows where compression effects are negligible. And for our last one, we have Mach number less than 0.3. So the Mach number is ang ratio ng speed of the flow to the speed of sound in the medium. So kapag ang Mach number is less than 0.3, the flow speed is much lower than the speed of sound. At ang changes in pressure due to the flow are minimal. In this regime, yung fluid behaves almost as if it's incompressible, even for gases like air. In other words, the density are negligible at these low speeds. So for our next topic, we have law of conservation of mass. The conservation of mass principle applies to both compressible and incompressible flow. So under mass, we have mass flow rate and volume flow rate. So under this section, both of them will be discussed. So ano nga ba yung conservation of mass? The law of conservation of mass dates from Antoine Lavoisier's 1789 discovery that mass is neither created nor destroyed. In other words, the mass of any one element at the beginning of a reaction will equal the mass of that element at the end of the reaction. So under this law, it states that mass can't be created nor destroyed. Ibig sabihin, hindi tayo pwede gumawa ng panibagong mass and hindi rin natin pwede tanggalin yung existing mass na meron ng isang object. So, for example, ano ba yung mostly natin ginagamit? Okay, for example, we have piece of paper. So, kahit punit-punitin mo yan, ang mangyayari lang dyan ay it will turn into smaller pieces. Still, the total mass of the paper remains the same before and after tearing. Next, we have mass in equals mass out. Ibig sabihin, mass going in the system is equal to the mass going out of the system. So if we account it all, the total mass will be the same at any point in time in any closed system. So ano nga ba yung equation natin for mass flow rate? So we have mass flow rate, some call it m dot, is equal to density times area times velocity. So for mass flow rate, basically it is just a mass per unit of time. So applying law of conservation of mass, na ang mass entering the system is equal to the mass leaving the system, therefore yung mass flow rate 1 is equal to mass flow rate 2. And then from this equation, yung mass flow rate is equal to density times area times velocity, i-substitute natin sa mass flow rate 1 and that will become density 1 time density 1, area 1, and velocity 1 is equal to density 2, area 2, and velocity 2. So ito, magkakaroon na tayo ng relationship ng density, area, and velocity under mass flow rate. So take note of this equation because this will be used for our sample problems later on. So we're now done with the law of conservation of mass. Now let's proceed to Bernoulli's equation. So Bernoulli's equation is primarily applicable dun sa incompressible flow, where the fluid's density remains constant. This is because the standard form of Bernoulli's equation assumes that changes in pressure do not affect the fluid's density, which holds true for incompressible flows like liquids and low-speed gas flows where Mach number is less than 0.3. So yung Bernoulli's equation, ito yung principle that states that for an incompressible, non-viscous fluid, the total mechanical energy along a streamline remains constant. So mathematically, it is expressed as pressure plus rho v squared divided by 2 plus rho gh is constant. So this equation shows us the relationship of the total pressure of any 2 point within the flow. Ibig sabihin, the total pressure at any point is always constant. So let me just show you a video from the efficient engineer. So sa bawat terms na ito represents a pressure. So the first term is a static pressure which is represented by P. Next is the dynamic pressure which is a function ng fluid density, rho and velocity V. And lastly is yung hydrostatic pressure which is yung pressure exerted to the fluid due to the gravity. So ito yung magiging kabuuan ng Bernoulli's equation in terms of pressure. Yung Bernoulli's equation ay kadalasang ginagamit to compare the flow at two different location. So pwede natin siyang i-rewrite into this kung saan yung point 1 and 2 ay nasa iisang streamline. So as you can see, walang significant change between points 1 and 2. So the potential energy term cancels each other out kasi magiging 0 na yung H natin. So again, keep this in mind because this will be useful as we solve for the sample problems under Bernoulli's equation. So ngayon, let us proceed na sa ating sample problems ng basic principle ng aerodynamics under law of conservation of mass. So for our first problem, we have question number 1. Find the mass flow rate of a liquid which is ang density ay equal raw sa 0.69 grams per cubic meter flowing through a 5 cm inside diameter pipe at 8 meter per second. So first, i-list muna natin yung ating given. Given natin ay density is equal to 0.69 grams per cubic centimeter. Tapos for our diameter, we have 5 cm. And for our velocity na 8 meter per second. So bago natin tayo magpatuloy, i-convert muna natin siya into kilogram per cubic meter kasi yung velocity natin is naka-meter siya. So, kailangan mag-match yung mga units natin for this. So, i-convert muna natin siya 0.69 gram per cubic centimeter times 1 kilogram divided by 1,000 grams times 1,000 cubic centimeter divided by 1. So, since may cubic centimeter tayo, erase din natin sa 3 ang 1,000 centimeter over 1 meter para makancel out natin yung unit na cubic centimeter. So, after solving for that, 0.69, okay, we have the result na 690 kilogram per cubic meter for our density. Now, for our diameter, i-convert natin siya from centimeter to meter. So, multiply lang natin yung 5 cm times 1 meter over 100 cm para makancel out yung centimeter. And makuha na natin yung 0.05 meter. And now, since ang required natin ay mass flow rate, i-input natin yung formula for mass flow rate which is density times area times velocity. So, in solving for so sa formula natin, ang hindi given is yung area. So, kailangan muna natin i-solve yung area. So, masasolve natin yung area using the formula pi diameter squared divided by 4. So, yung diameter natin is square lang natin siya. So, pi times 0.05 meter, tapos isi-square natin siya, divided by 4. So, we will have an answer of 0.001963 meters square. So, nakuha na natin yung area. Since nakuha na natin yung area, i-input na lang natin yung mga given values na meron tayo. So, for density, we have 690 kg per cubic meter times 0.001963 square meter times 8 meter per second. So, input natin siya sa ating calculator, and then it will result to 10.836 kg per second. So for the question, find the mass flow rate of a liquid na may density of 0.69 grams per cubic centimeter flowing through a 5 cm inside diameter pipe at 8 meter per second. So yung mass flow rate, nakuha natin siya using mass flow rate na formula. So nakuha natin siya, yung sagot natin ay 10.836 kg per second. So for our second problem ng aerodynamics basic principles, under Bernoulli's equation, we have consider water flowing through a converging tunnel as shown and discharging freely to the atmosphere at the exit. What is the gauge pressure at the inlet? Assume a flow to be incompressible and neglect any frictional effects. So under this, meron tayong graph, ay meron tayong figure na pinakita. So ang gagawin natin is, as usual, ilagay natin yung mga given na meron tayo. We have diameter na 150 mm. For diameter 2, we have 75 mm. And then for velocity, we have 1.2 meter per seconds. So again, kailangan mag-match yung mga unit natin, kasi yung sa diameter natin, we have millimeter, and then for velocity, we have meter. So kailangan muna natin i-convert yung ating diameter into meter din para mag-match yung mga units natin. So for our diameter, let us convert into meter by multiplying it by 1 meter over 1,000 millimeter para makancel natin yung ating unit na millimeter. So using calculator, ang makukuha natin na value ay 0.15 meter. And then for diameter 2, let's multiply 75 millimeter by 1 meter divided by 1,000 millimeter. So i-calculator natin, and makukuha natin dyan ay 0.075 meter. So since na-convert na natin siya, let us now proceed doon sa ating solution. So for Bernoulli's equation, we have an equation na pressure 1 plus rho times velocity 1 squared divided by 2 plus rho gh is equal to pressure 2 plus rho v2 squared divided by 2 plus rho gh squared. So since plus rho gh sub 2 pala, So as you can see dito sa ating figure, yung height natin from point 1 at point 2 ay equal lang. So pwede na natin iset yung height into 0. So maka-cancel out na yung buong rho gh na term. And also yung pressure natin, nakalagay dito sa ating figure na yung pressure 2 ay equal lang sa atmospheric pressure, and ang pinaka-concern naman natin dito ay yung ating gauge pressure. So pwede na rin natin siyang ma-cancel out. So i-rewrite natin yung equation. Pressure 1 plus rho v1 squared divided by 2 is equal to rho v sub 2 squared divided by 2. Tapos i-transpose lang natin yung isang term. So we will have pressure 1 is equal to rho v squared v sub 2 squared divided by 2 minus rho v1 squared divided by 2. And then, ang magiging result na after that is pressure 1 is equal to rho divided by 2 multiplied by V sub 2 square minus V sub 1 square. Bale, finactor out lang natin yung equation na nakuha natin. And then, since wala tayong volume 2, kailangan muna natin siyang hanapin using yung continuity flow na formula, which is A sub 1, V sub 1 is equal to A sub 2, V sub 2. So, i-isolate lang natin ng V sub 2 since yun naman yung hinahanap natin. So, V sub 2 is equal to A sub 1 times V sub 1 divided by A sub 2. Since wala tayong area 1 and area 2, kailangan din natin hanapin yung ating area 1 and area 2 by solving it using the area formula. So, ang formula natin, kagaya lang ng ginamit natin kanina under law of conservation of mass, area is equal to pi diameter squared divided by 4. So, let us start with area 1. So, for area 1, it is equal to pi times 0.15 meter squared divided by 4. So, we will get 0.017671 square meter. And the next, for area 2, let's use pi, ganun pa rin, same formula, pi d sub 2 square divided by 4. So, palitan lang natin yung ating diameter into 0.075 meter square. At ang makukuha natin na result for that is 0.004418 meter square. Since nakuha na natin yung dalawang area, pwede na natin siyang i-substitute doon sa equation natin in solving for the velocity. So, i-substitute lang natin siya. So, area 1 is equal to 0.017671 square meter multiplied sa ating velocity 1 na 1.2 meter per second. Ito po ay given kanina. Divided by 0.004418 square meter. So, makakukuha tayo ng 4.825830693 meter per second. So, since nakuha na natin lahat ng values, isubstitute na lang natin siya sa ating working equation in solving for the pressure 1. So, since water yung pinag-uusapan natin, yung density na gagamitin natin is yung standard density for water, which is 1,000 kg per cubic meter divided by 2. And then, yung nakuha natin na velocity 2 na value kanina, which is 4.825830693 meter per second, is-square natin siya, minus yung 1.2 meter per second squared. So, after that, upon calculating, ang makakuha natin na value is pressure 1 is equal sa 10,924.320.32094 Newton per meter square. So, ayun, na-solve na natin ang dalawang equation, ang dalawang problem ng basic principles ng aerodynamics, which is under law of conservation of mass and Bernoulli's equation. To wrap up everything, today we learned that first, incompressible flow refers to fluid flow in which the density remains constant throughout the motion of the fluid. Yung assumption na ito is especially valid sa mga liquids which are nearly incompressible at sa mga gases at low speeds, where yung Mach number nila is less than 0.3, where yung pressure changes have negligible effects on density. Tsaka when working under the assumption of incompressible flow, it simplifies that many fluid dynamic equations as it allows us na makapag-focus only doon sa velocity, pressure, and cross-sectional area without worrying about the variations ng fluid density. Next is we have conservation of mass. So the law of conservation of mass, recall yung diniscuss natin kanina, states that mass cannot be created nor destroyed within a closed system. So, in the context of fluid flow, this law is expressed through the continuity equation, which dictates na yung mass flow rate ay kailangang mag-remain constant at all points along a streamline in steady state flow. And then lastly, yung Bernoulli's equation, ito yung key principle in fluid dynamics na nag-explain kung paano yung pressure, velocity, at saka height interact in a flowing fluid. So sa incompressible flow, yung Bernoulli's equation states that yung sum ng pressure energy, kinetic energy, tsaka yung related sa fluid's velocity, yung potential energy na related naman sa height, remains constant along a streamline. So in simpler terms, as a fluid flows through different parts of a system, its velocity increases and then its pressure naman decreases and vice versa, while the total energy remains the same. So, ano nga ba yung relevance kung bakit natin to pinag-aaralan? So, by understanding these interconnected concepts, yung mga engineers and scientists can design systems na pwedeng mag-control and manipulate doon sa fluid flow, ensuring efficiency and stability sa applications such as aircraft design, hydraulic systems, and fluid transport mechanism. So yung mga principle na to ay hindi lamang theoretical foundations but also have wide-reaching practical applications na nagsishape sa modern engineering and technology. So sa incompressible flow, the law of conservation of mass and Bernoulli's equation ay nagpro-provide ng essential tools para maintindihan natin ang pag-predict ng fluid behavior in a variety of real-world systems. So nag-offer sila ng mas simplified but powerful way to approach complex fluid dynamics problems, making them indispensable in both academic and industrial concept. So, ito na yung katapusan ng aking presentation. I hope na you learned something. Once again, I am Carl James Solosod from BS831, and this is my discussion about the basic principles of aerodynamics, which tackles about the law of conservation of mass, the law of incompressible flow, and Bernoulli's equation.